Alright, so let's continue on standard deviation of sample and population. So there's a faster formula to compute the standard deviation of sample, which is this. So standard deviation S equals square root of n times summation of x square minus summation of x parentheses square divided by n times n minus 1. So basically, in order to use this formula, you need to find the values of sample size n, summation of x, and then summation of x squared. So here, take the bank consistency data set as the example. Our sample size n equals 6. There are basically 6 values in sample, and summation of x equals 30. We're adding all the values, data values, 6 plus 5 plus 4 plus 4 plus 5 plus 6, and then we end up with 30. And summation of x squared, we basically add up each square terms. 6 is equals to 6 squared plus 5 squared plus 4 squared plus 4 squared plus 5 squared plus 6 squared equals 154. So apply the formula S equals to this. We put in all the data values, put in all our results. We get square root of 506, which is 0.89. So basically, by using this formula, we get to the final answer slightly faster. Next, let's concentrate on how to compute the standard deviation of the population. Standard deviation of population, we use sigma to represent population standard deviation equals square root of summation of parenthesis x minus mu parenthesis square divided by capital letter of M. So here mu represents population mean, and sigma is the standard deviation of the population. And dividing, and here capital letter N represents the population size. So you can do in Excel easily by typing std EVP to compute the population standard deviation. And that's a very simple way to estimating population standard deviation and then a sample standard deviation. We're basically just using highest value, which is maximum of the data set, minus lowest value, which is minimum. We get a result, we divide by 4. And we basically just get an estimate of sample standard deviation or the population standard deviation. And the theorem behind this, we're going to talk about this on chapter 6. Okay, let's look at an example of how to compute a sample standard deviation and population standard deviation. So this example is about a statistics class of 20 students. They obtain the following grade. So we get students' name here. We get their grade next to it. So to rapidly approximate the mean, we take a random sample of 5 students and we pick at random. We pick Nancy, Mary, John B, Betty, Lena. So our sample mean equals to parenthesis of 78 plus 92 plus 64 plus 83 plus 78 parenthesis divided by 5. We end up with 79. And our standard deviation equals square root of 78 minus 79 square parenthesis square plus 92 minus 79 parenthesis square plus 64 minus 79 parenthesis square plus 83 minus 79 parenthesis square plus 78 minus 79 parenthesis square. We get a result divided by 4. So eventually we get square root of 103. And square root of 103 basically it's approximately equals 10.15. So we figure out the sample mean, which is 79, and sample standard deviation, which is 10.15. And this population mean is obtained by adding all grades, right? So adding all these grades, all 20 grades, and divide by 20, we get a 79.95. So the population variance is equals 10.71. So basically computed by following table. So put on student's name, put on their grade, and we get a table. We get a particular column called x minus mu, which is each data value minus population mean. So end up we get this particular column, and then we square that, and we get this particular result of the square terms. We add them up, get 2293, and we divide by population size 20. We get 114.6. Then we take square root of that. We get 10.71. So you can see our sample mean is very close to the population mean. Our sample standard deviation is very close to our population standard deviation. So that means this sample is very good representation of a population. So let's move on to the variance and the coefficient of variation. So variance is basically equal to square of standard deviation. For the sample, the sample variance would be equivalent to x squared. For the population variance equals sigma r squared. So general terms referring to variance, it's basically dispersion, spread, variation. Let's take a look at an example, right? So in class grade case, sample standard deviation was 10.15. Therefore, our sample variance x squared equals 103. The population standard deviation was 10.71. Therefore, population variance equals to 10.771 squared, which is 114.7. Next, let's move on to a term called coefficient of variation. So coefficient of variation, we use CV to represent it. And we basically take the first letter of coefficient and variation. We get CV. And this coefficient of variation describes the standard deviation relative to the mean. So CV for sample equals to sample standard deviation S over sample mean x bar. So equals to x over x bar. And coefficient of variation for population equals to sigma over mu. So in previous example, coefficient of variation for sample equals 10.1 divided by 79, which yields 12.8%. And see, coefficient of variation for population equals to 10.71 divided by 79.95, which is equals 13.4%. And coefficient of variation allows us to compare dispersion of completely different data set. And let's take a look at an example, right? So for band consistency data set, data value is 654465. So mean x bar equals 5, standard deviation S equals 0.9. So our CV equals to 0.9 divided by 5 equals 0.18. And for class grade data set, for that sample case, so our sample mean equal x bar equals 79. And sample standard deviation equals 10.1. So our coefficient of variation CV equals 10.1 divided by 79, so equals to 0.13. So variation of a consistent band consistency data set is larger than that of the class grade data set in relative terms. So coefficient of variation allows us to compare variation of completely different data sets, right?